Okay, so here's a small electric motor that I've got on the bench, and I've chosen this one because right here the carbon brush goes in the back here down into the body of the motor. This small piece here is actually just a spring which is keeping it pushed into the motor like this, in this direction. The brush is connected up with a small wire here up to the main electricity supply, which comes in through here. Now if I turn the motor a little bit, you can see in here is the commutator, and so each of these segments is kind of separate from the other, and the segments join up on opposite sides, so there's one on either side that supplies current to a loop in the rotating core that provides a magnetic field. And the idea is that as it rotates, the correct loop, there's many loops stacked up like this in the core, the correct loop in the core is energized by the commutator being contacted by the brushes on either side. The brushes do wear down, which is why you might find spare ones, and that's a common fix for electric motors, is just check the brushes. They might be all burnt up or completely worn down. This little motor I pulled out of maybe a Hoover or something like that, and if I do something, if I indulge in rudimentary safety precautions like this, and maybe do something like that, you can actually see I've got it wired up ghetto style to a plug, and when I plug it in, so you may have been able to see there was some slight sparking down here where the carbon brush was touching the commutator. That's relatively normal, although obviously you don't want too much of it because it's presumably a sign of poor contact. You can often clean the commutators. This one's quite dirty, but you can, if you can pull it out, remove the brushes, maybe, or even not removing the brushes, you can clean these commutators to give a fresher copper surface for the carbon brushes to contact on. And there you go, there is a tiny little video illustrating the place and purpose of carbon brushes in an electric motor.